CICU devices.
Impella. Impella components. Impella CP from tip to toe, Part 4. This video is a continuation of our previous video, Impella CP Components Part 3. The link can be found in the description. The repositioning unit of the Impella CP catheter is composed of a sheath, a guide wire access port, and suture pads. The sheath has a total length of 18 centimeters, with 12.5 centimeters remaining beneath the skin and within the arterial vessel. A gradual taper from 15 French to 9 French allow the sheath to closely conform around the catheter shaft, minimizing the risk of thrombus formation and protecting against limb ischemia. A dedicated guide wire access port enables the introduction of a 0.035 inches guide wire into the arteriotomy before catheter removal, with a stylet maintaining the patency of the lumen during the support. The repositioning sheath also incorporates a suture pad designed to stabilize the catheter and sheath at the access site. This pad provides a secure anchoring point, allowing sutures to be placed without compromising the integrity of the arteriotomy or the catheter shaft. By reducing unwanted movement, the suture pad helps prevent vascular trauma, minimizes the risk of accidental dislodgement, and contributes to overall hemostasis. The next component is the sterile sleeve. It is also called the anti-contamination sleeve and is a fundamental component of safe device management. The sleeve is a transparent barrier that is attached to the repositioning sheath after the peel-away introducer is removed at the end of the insertion procedure. Once anchored with its locking rings, the sleeve extends to cover the proximal extracorporeal segment of the catheter, maintaining a sterile environment from insertion to bedside care. Its role is critical. It prevents contamination of the insertion site, reduces infection risk, and allows clinicians to manipulate or reposition the catheter without breaking sterility. It measures approximately 48 centimeters from end to end and is manufactured from transparent polyethylene. The transparent material ensures continuous visual inspection of the shaft for measuring depth and detecting kinking, blood ingress, or damage, while its flexible design supports secure handling during prolonged support. At its proximal end lies the twist lock mechanism, which secures the sleeve firmly to the repositioning unit, preventing accidental detachment in the event of traction. Immediately distal to the twist lock is the Tahi-Borst valve, a critical component designed to grip the catheter shaft through clockwise tightening. This feature minimizes the risk of catheter migration or displacement during patient care and bedside manipulations. In this video, we show how to secure the sterile sleeve. More information about catheter securement and nurse management is available in this video. The link can be found in the description. At the proximal point of the Tahi-Borst valve begins the transparent portion of the sterile sleeve. It is at this point that it is advised to measure and document the inserted catheter length, using the centimeter markings imprinted along the shaft. Accurate documentation at the Tahi-Borst junction is essential for tracking catheter depth, ensuring correct positioning within the left ventricle, and facilitating troubleshooting in case of migration or suspected malposition. At the distal end of the sleeve is an anchoring ring, which is engaged after the sleeve is fully extended along the length of the catheter, covering the extracorporeal segment up to the vicinity of the red handle. By locking the anchoring ring with a clockwise rotation, the sleeve is stabilized, ensuring continuous protection of the catheter against contamination while preserving ease of access and visualization. The red Impella handle, also referred to as the red plug or red hub, is a key structural and functional component of the Impella heart pump system. It acts as the central interface between the catheter and the automated Impella controller, integrating essential mechanical and electronic functions required for safe and effective device operation. The red hub serves as a convergence point for multiple system elements. From the distal end, the Impella catheter itself emerges, carrying within its lumen the three-phase power cable, the optical fiber, and the purge channel. On its lateral aspect, the purge line is connected via the side arm, ensuring continuous fluid delivery to the catheter system. And at its proximal end, it receives the white cable, which encloses the power lines, data wires, and the optical fiber. Each connection point on the red hub is fitted with a gray rubber protector. These protectors are designed to stabilize the junctions and minimize the risk of kinking of the lines or cables, thereby preserving the integrity of power delivery, data transmission, optical signals, and purge flow. When the red plug is opened and its internal structure examined, several key components can be clearly identified. At the proximal aspect, the entry point of the data wires, power lines, and optical fiber can be observed. A green printed circuit board is also visible, hosting multiple integrated chips. Among these, it is an EEPROM memory system, which stores operational data from the catheter. This non-volatile memory ensures that essential information is preserved, even after the Impella catheter is disconnected or the controller is exchanged. In addition, a fiber optic coupler can be identified within the red hub. This element provides the interface between two fiber optic cables, maintaining precise optical continuity and secure transmission of signals critical to device performance. Finally, at the distal end, we can find the purge line, power wires, and optical fiber entering into the catheter, completing the transition from the hub to the intravascular portion of the system. The white connector cable or driveline is attached to proximal end of the red plug. It connects the Impella catheter to the automated Impella controller. Its main role is to transmit the power, optical fiber, and electrical signals that allow the controller to monitor and regulate pump performance. Additionally, it serves as the structural support for the purge system. The cable's design also minimizes electromagnetic interference, maintaining accurate signal transmission and overall system reliability. The driveline measures approximately 2.5 meters in length. This length ensures that the console remains outside the sterile field during implantation while providing sufficient slack to prevent mechanical tension during patient transfers or passive mobilization. It also offers an ideal balance between operational convenience and patient safety, minimizing the risk of connector strain or accidental dislodgement, while maintaining stable electrical and optical performance throughout device operation. Clips along the cable are used to fasten the purge tubing securely to the cable body, maintaining an organized and tangle-free layout from the insertion site to the console. This integrated routing system minimizes the risk of kinking or accidental disconnection of the purge line. In this video, we show how to secure the purge tubing into the clips along the white cable. More information about purge tubing care and nurse management is available in this video. The link can be found in the description. If the driveline is transversely cut with a scalpel, the following internal structure is revealed. The outermost layer consists of a medical-grade white silicone jacket, engineered to provide robust mechanical protection as well as resilience against physiological fluids. Beneath this primary insulation, a fine metallic braid mesh encases the cable bundle, serving as both a physical reinforcement and an electromagnetic interference shield, crucial for maintaining signal integrity and device reliability in complex medical environments. Within this reinforced assembly, several sub-bundles are meticulously arranged to deliver specialized functions. They include power and data wires, along with the optical fiber cable. The internal configuration is carefully twisted or spiraled to enhance flexibility and minimize mechanical stress during handling and movement. The Impella CP white cable terminates in a circular multi-pin connector, designed for precise electrical and optical interfacing with the console. The connector features 12 gold-plated contact pins, arranged concentrically around a central port, which houses the optical fiber used for real-time pressure sensing in the Smart Assist version. The contact pins are slightly elevated above the plastic surface, forming male terminals that mate directly with the corresponding female contacts inside the console port. These gold-plated pins guarantee low-resistance transmission for power and data, whereas the central optical channel enables accurate signal delivery from the integrated fiber optic pressure sensor. Finally, on the outer contour, 3 lateral tabs serve as orientation keys, ensuring the connector can only be inserted in the correct position and preventing accidental misalignment. Continues on Part 5.
If you've enjoyed our video, please press the like button and subscribe to support us so we can continue creating quality content like this.